Hello everyone. Let me present a very small video explaining about the manipulation in a data frame using R. So for this I'm going to use a use case from the R dataset library. Dataset library presents a collection of use cases, and if you want to check all the use cases which are present in the dataset library, you can simply use this command library inside a bracket health equals to inside inverted comma the data set, right? So let's check it. So this is the dataset package, and these are the use cases that we have. The first use case that we have is air passenger and so on. And what I'm going to do is I'm going to pick up a dataset called iris dataset, this one iris dataset, to explain the manipulation in the data frame. This is the iris dataset which can be seen over here, right? And let's check the structure of the iris dataset first. This is the structure of the iris dataset, which consists of 150 observations, meaning 150 rows with 5 variables. These are the variables, and of the 5 variables, for our numeric variable, the last one is a factor variable with 3 labels. So you can check the head. This is a head with 3 observations, 1 to 3. You can, if you give 5, then it will give 5. If you don't give anything, then default is 6. Now you can also check the view of the you can check the whole dataset using view command, view function. This is the one, right? This is the dataset. So the variables are septal length, septal width, petal length, and petal width, and this is the species. And then let's do one thing. Let's start manipulating the dataset now. Let me select the first 2 columns of the dataset and all the rows. For that, the command, the function is the command is iris dot the name of the dataset first, followed by the square bracket. You have a comma over here. The place before the comma is the row. If you keep blank, then you're selecting all the rows, and after the comma, then you're going to select the columns. So if you are selecting column number 1 and 2, you can write C function then 1 comma 2. So you have selected the first 2 columns and not discarded the remaining columns of the data set. And tail is this. You can also write, so if you are selecting continuous number, you can also write like this. Continuous number, you can use this column if you are selecting continuous number, right? Continuous column. So similarly, if you want to select the rows, some particular rows, then the same function, the same command, iris, the dataset name, then the square bracket, then followed by the row numbers that you want to select, comma, and then if you keep this blank, that means what, you're selecting all the columns. If you write a particular number over here, you're selecting only that particular column and these rows. So I'm keeping all the columns and selecting row from 11 to 19. So you don't need this C function if you want to write colon a continuous number. This is the one, right? So if you want to select some particular numbers not in continuity, then the C function will come and then write down the row numbers in this. So row number 2, 11 and 15, 2, 11 and 15. Now I would like to omit the last variable in the dataset, which is species, which represent a factor variable, and return only the numeric values of the dataset. So what I've done is I'm keeping this blank, meaning what, I'm selecting all the rows and selecting these columns 1 to 4. So this is the one, and you can also do like this. Instead of writing 1 to 4, you can simply write the row, the column number which you want to drop. The column number which you want to drop, that is 5, and put a minus sign in front of that. This also will give the same output, right? Will give the same output. Now, having selected the numeric variable, let us compute the correlation coefficient of the numeric variable using the function COR is for correlation. If you put the whole data set inside, then it will compute a correlation matrix. This is the correlation matrix of the four variables, between the four variables, right? Now we have seen that in the structure of data set, species, this species was having three factors, but only two species was having three levels, right? A factor with three levels. Only two levels are visible over here. If you want to check all the levels in a factor variables, what you do is you use this command. Levels, inside the bracket you select this species using a dollar sign. Remember, to access the variable of the data frame, then you will have to use a dollar sign, right? So data frame dollar sign, the variable that you want to select. This is the one, right? So you have three factors. The factors are Sentosa, versicolor, and virginica. Now, if you want to count if you want to count the level of each of these, if you want to count the number of Sentosa, versicolor, and virginica, you can use the table function and put this species iris data set $ species. So you are going to have, say, let's see how many. 50 is, all the three levels are of 50 is. So you can also have a bar plot of this. I've done the bar plot. The bar plot is table, the tabulated value will come over here, and then I'm using the rainbow color. Instead of rainbow color, you can also use this blue, green, and red, right? This also will have the same. It's all up to you how to play with the colors, right? And this Y lim will give you'll be using this. You can play with the height of the y-axis. I've given 60 as the height because the highest bar is of 50, so ideally it should be a little above the highest bar. X left is the level of the axis, Y left is the level of the y-axis, and main will you will be able to write the name of the bar chart. So using main. So this is how you plot a bar chart. You can also use box plot to plot this numeric variable. This is the box plot of the four numeric variable that you have. Now, if you want to avoid using a dollar sign to access the variable, the alternative is to use the function called attach. So if you use the function attach and put the data frame inside, then every variable of the data frame you will be able to access without the dollar sign. See, try to access this one before doing the attach function, right? Let me detach first. I've already attached before, so let me detach first. Detach is not working. I've already attached. That's why the variables are separated, right? The variables are separated because I have already used this attach before. So for you, if you're using for the first time, you'll have to use this attach to access the variable without the dollar sign. Remember this. If you want to access the variable without the dollar sign, use this function. Now, since I've used this function, attach function, I can now use the variables without this dollar sign. Now over here, what I'm going to do is I'm going to sort the data frame on the basis of the septal length. So sorting is going to be done over here only on the basis of the septal length. Let's see. So I've done the sorting using this particular variable. So it's starting from the smallest and it's going down to the biggest, right? So if you want the sorting on the reverse order, starting with the largest and going down to the smallest, then you simply put a minus sign in front of the variable. The sorting is in the reverse order now. Now remember, in the sorting of vector, what we had done was you had used this function. So in the case of sorting of data frame, order function is the one. So I'm writing over here, or the order function for sorting data frame, right? Sort for sorting vector, order for sorting data frame. This is sorting on the basis of only single variable. If you want the sorting to be done on the basis of two variable, this is how you write. This is the primary variable. The one you write first is going to be primary variable followed by the second variable. So let's do the sorting and see. So I done the sorting on the basis of septal length and septal width. So septal length is starting from the smallest and going down to the largest. Now see over here, from the second row, second value till the fourth value are having the same. From second to four are having the same values. So within these same values, if you check over here, it's going down from the smallest to the largest. And this is how we had. This is why we are given this command. Sorting on the basis of the septal length first, and within that you do the sorting on the basis of septal width. So if you want septal length to be sorted in the reverse order from the largest to the smallest, and septal width on the basis of from the smallest to the largest, this is the command. This is the command. This is on the basis of largest to the smallest. This is from the smallest to the largest. Let's check it. From the largest to the smallest, concentrate on these four values and come over here. This is from the largest to the smallest, and this is from the smallest to the largest. This is all up to you how you do it. And if you want both from the smallest to smallest, this is how you do it, right? It's all up to you how you play with. Again, this concentrate on this four. This is from this largest to the smallest because you have given minus sign over here. So it's all up to you how to play with this. Now let's come down to subsetting of a data frame. Subsetting function can be done using subset. S-U-B-S-E-T. Subset function will subset your data. You will be able to subset the data frame using this function on the basis of certain condition. This is one of the conditions that I'm going to do. So what I'm going to do is I'm going to subset the data from iris using the function subset on the basis of this. So I want only those data to be included in S1 whose septal length is greater than 5. Let's see. So I have checked the head. So septal length should be greater than 5, remember, only then it can include an S1. So septal length are all greater than 5 and it's included in S1. This is the head. Now you can also check the tail of this S1 just to cross check, just to double confirm. Over here again it's all greater than 5. So subsetting, using the subset function, you'll be able to subset a data frame on the basis of certain condition. This is a single condition. You can also have a double condition. I want only those data from data frame to be included in S2 with these conditions. The septal length has to be greater than 5 and the septal width is less than 2.3. Let's check it. Septal length should be greater than 5 and width less than 2.3. I have only for 3 observations with this condition, and these are the 3 observations. Observation number 63, 69 and 120 satisfy this condition. So it's all up to you how to play with this these particular conditions. Now let's also talk about the split function. Split function, you will be able to split the data frame on the basis of certain condition. The conditions that I'm putting over here is species should be versicolor. If the species is versicolor, it will be stored in SP with this logical value. If the species is not versicolor, it will be stored in SP with this logical value. Let's check it. So split the data frame that you are going to work with and the condition. So let me check this one. So I have done it. I have stored all the versicolor because true is for versicolor in T now, from the SP in T, and all the other variety in F from SP using false. Let's check it. Let's check it. This is T for versicolor. You should only have versicolor in T, not any other species. So this is only versicolor. Let's clear this screen and check it. This is only versicolor. You can also check using the level function instead of doing like this. Let's check using the level function. Level T and species. No. This is not working. This is not working. Okay. So in T we have only the versicolor, and in F you'll have all the other varieties other than versicolor. Let's see. You should have the Virginica and Sentosa in F, because versicolor is in T and the remaining varieties in F, right? So this is how you work with the split function. Now let's come down to the apply. The apply family function. The apply family functions, we will have the apply, sply, apply, supply, and tply, right? So let's start with the apply first. The apply function. This function works on the data frame or matrix and produces vector as output. This function has three main arguments: the data set, the data frame or matrix, and then margin stands for either column or row under the function that you want to have value. So let's check the x4. x4, remember, it was the numeric variable. We have excluded the species from the IRIS dataset and stored in x4. So in the x4, I want to see the mean value of septal length, septal width, petal length, and petal width. And for this is the command. This is the function. Apply the data frame. 2 stands for column, and mean. Mean is for average. So these are the values. Similarly, the standard deviations of this particular three of these four variables: the maximum, the minimum, and if you want to combine all this and put it in the tabular form, then you can use rbind, binding rows. R stands for row, and binding row binding. So I'm binding mean, standard deviation, maximum and minimum, and putting it in one table. This is how you do it. The same thing can be done with the rows by replacing 2 by 1 in all this, right? So you do it by yourself. Now let's come down to lfly. lfly, this function works on a vector, array, data frame, or list, and then return a list. It will produce a list. So let's see how it works. So what I'm going to do is I'm going to find out, say, the quantile of the 4 variables, right? First quartile, the second quartile, and the third quartile of the 4 variables, and it's going to come out in the form of a list. So it has come out. The first list is for septal. The first list is for septal length, the second for septal width, the third for petal length and petal width, right? So now let's now let's come down to this. You can also do the same for any other average. Instead of, say, quantile, if you want to do it for mean, that also you can do it. You'll have to delete the probabilities in the case of mean. So these are the mean values of the 4 variable. See, sply is going to produce the same, going to work almost in the same manner as lply. Only difference is this was producing values, the output in the form of this, and this is going to produce values in the form of table. So this will be this is going to have a better layout than this one. Let's check it. I'm giving the same command. The only thing that I have changed is sply instead of lply, right? So the outputs. Septum length, first quartile value is 5.1, 5.8 second, and third quartile is 6.4, and similarly for the other variable. So I'll suggest, if of the two, this is having a better output, better display of the output. So I will prefer this one over this. Now let's come down to tply. Tply. Say this function is useful in computing the various measures such as mean, median, sum, standard deviation, etc. for each factor variable in the vector. So let me do it. So I'll like to compute the I'm selecting the petal data, right? I don't have to put a $ now because I've already attached the data frame, so this $ is no longer required. You don't have to put this one. Let us stop using this. I'm not using this one. I'm deleting all this. This is to be used only if you do not want to use the attach function. Remember this. So let me do it. I've selected the petal length, and I would like to divide this petal length on the basis of species and then compute mean. So let me repeat again. I have selected the petal length and I'm dividing this petal length on the basis of the species and computing the average. Let me clear the console first. So I've done it. I've divided the petal length on the basis of the species Sentosa, versicolor, and virginica, and computed the mean. The same thing will be done for the standard deviation, and then what? The maximum, the median, and the mean. If you want this, all this in the tabular form, what you can do is, so you can store this in a variable t1, t2, t3, and t4, and finally use rbind to put it in the tabular form in one place. Let's do it together. So I'm compiling it again, storing all this calculation in t1, t2, t3, t4, and t5. So let me use rbind to put all this in a tabular form. The first one is average. Average is t1. The second one is standard deviation, STD, T2. The next one is what? Maximum. And this is T3. And next one is what? Let's finish it here. So this is how you present the calculation in the tabular form. Thank you very much. Thank you very much for giving a patient hearing. I hope you have understood what I'm trying to explain to you. Thank you very much. Thank you.